So the big idea today is two things. One, we're going to try to find angle measures. Two, we're going to solve right triangles. And when you see those directions, solve the right triangle, it means find all the missing parts. Okay? So they're going to have to give you 3 pieces of information, and then from that, you'll have to find 3 more pieces of information. I want to remind you one more time of the ways that you have prior to this lesson to solve a right triangle. So one way is with Pythagorean theorem. So if you can solve with Pythagorean theorem, that's what you should do because it's going to give you an exact value. If it's not Pythagorean theorem, or you can't solve because you don't have enough information, it might be a special right triangle. So 30, 60, 90. What's across from the 30? 60, 90. Or it might be what special right triangle? Okay, 45, 45, 90. What's across from the 45s? Okay, so S on both of them, and then what's across from the 90? S squared roots of 2. Or it might be that it's a special right triangle where what's happened? An altitude's drawn from the right angle, right? And so then we have these sides. I'm just going to make up some letters this time. Okay? I don't know why. All right, so then let's write down what our shortcuts are, our rules that we learned. I heard b squared equals x times y. That's altitude squared equals part times part. And then the other one using leg A. Good. A squared equals x times and then x plus y because we're going to add those two together to get the whole. Or it could be good. So those are your options that you learned prior to this lesson. And then we learned SOHCAHTOA, which told us that sine of the angle is equal to which two sides? Good. And cosine of the angle is equal to? Adjacent over hypotenuse. And the last one, tangent of the angle is equal to? Awesome. Okay, so these are our 3 trig functions, which is our 4th way to solve and our last way, but it is our last option. We don't use this unless we have to use this. We first check to see can we solve it one of these ways because these give us exact in simplest radical form answers. These give us rounded values, okay? So keep that in mind for the test. Again, you're going to know you can't use trig because if it doesn't say to round, you shouldn't have an answer that needs rounded, okay? And this is what always kills me when I put at the notes, and this happened to a few of you on the last test. Don't round unless it tells you to. And then I had answers like this. Okay, that is rounded. You stopped. You can't keep writing forever, so this is a rounded answer. When I say don't round, that means it needs to be in fraction form or in simplest radical form. Don't use a calculator to get your answer. Do it by hand so that it's exact. Okay? That's what I mean. Okay, so let's look at some problems and information in here. I'm going to come back to this at the end, so I'm going to ignore this for right now. Maybe, if I can hit the buttons right, and skip this one for right now. Okay, so I want you to understand from Algebra 1 why we're going to do what we're getting ready to do. So what we're going to try to do is solve for an angle. So maybe we want to find this angle. And by the way, this may not be in your notes. Okay? So, by the way, when you get to pre-calc calculus, they will call these angles with Greek letters, like alpha, theta, beta. So you'll see things like alpha, theta, and beta when you're looking at those, and it's more like beta, okay? And there's gamma, there's all kinds of Greek letters, but they will mainly use alpha, theta, and beta a lot when they're talking about angle measures. And they'll use variables when they're talking about a missing number or side lengths instead of the Greek letters. So when you see those Greek letters, it's often referring to angles. So I'm going to use that in my notation today, okay? So if I want to find this angle right here, theta, And maybe the problem gives me that this side is 3 and this side is 6. And again, it has to be what kind of triangle for this whole chapter? Right triangle. Okay, so what you're going to do is the same idea as what we started with yesterday. You're going to label the sides that you know. And you're trying to find this angle. So what would we call this side? The opposite side compared to this angle. And what is this side? Hypotenuse. Okay, you're not going to label the other side, because if you do, then you're going to get confused about which trig ratio, can't find my words, which trig ratio should you use. This will tell you which one to use. So label the sides you know. Which trig ratio uses opposite and hypotenuse? Sine. So you're going to write down sine of your angle. What's your angle called? Theta. Equals, and then you will write what over what? 3 over 6. Okay? And you could reduce that if you want to. What's 3 over 6? 1/2. Okay, at this point, what might you think you need to do to solve for theta? Okay, ignore this for right now on the video. Okay, I'm going to come back to that. Tyler?
So why do you call it theta?
Again, you can call it anything you want, but as you move into pre-cal and calculus, they usually use Greek letters to represent angle measures instead of our typical English alphabet with A's, B's, C's, D's. You can use anything you want. You can even call it A or B or whatever you want to call it, but I'm just trying to get you used to that notation for pre-cal. Okay, so what do you think you would do if you hadn't seen the video and you wanted to solve for theta? You would probably think divide by sine, right? So take your calculator right now and type in 3 divided by 6 divided by sine. It says error, right? Okay, because first of all, the sine is nothing by itself. It's a function of an angle. So you have to have an angle measure with it. Just like yesterday we kept saying, keep the tangent of 32 together. Keep the sine of 15 together. It's all one number. So you can't just divide by the sine. Another way to think about it, or to help you understand why in the video it's telling you what to do, is do you remember in Algebra 1 when you had something like this? And you wanted to move the variable to the numerator? If you moved it up, what happened to the exponent? It's a -1. Or maybe you learned it the other way around in Algebra 1. If you had x to the -1, did you learn that you could rewrite that as 1 over x to the +1?
Oh, yeah.
Okay, that's going to be hard for you then when we get to Algebra 2 second semester, because we will be talking about rules for exponents and solving, and they're going to get a lot harder than something as simple as this. But right now, if you didn't know that, if you have a negative exponent, you can move that to the denominator and it makes the exponent positive. Okay? So if I wanted to solve for the sine, and I can't divide by sine, then that means I could think about this as if my sine's in the denominator, I could move it to the numerator with a -1. So if I say instead of dividing 3/6 by sine, I'm going to take 3/6 and I'm going to multiply it by the sine to the -1. Does that make a little bit of sense, the connection there? Okay, so we call those the inverse sine functions, and basically they undo each other. So what's going to happen, and I want to show you over here on the board real quick before you start typing it all in. The inverse sine is like dividing by sine, and so what happens with the sine and the inverse sine? It cancels out, right? It's like saying sine divided by sine, those are going to cancel out. So if I take the inverse sine on the left, those cancel, and whatever I do to the left side of the equation, I have to do to the right side of the equation. So now my theta is isolated all by itself, which is what I'm looking for, and it's the inverse sine of 3 over 6, or 3/6. And when you plug that in, it was equal to 30. So it's 30 what? Degrees, because we're looking for an angle. Yes. Yes. So it's where your sine, cosine, and tangent are on your calculator. You need to hit second sine, second cosine, or second tangent. But remember, what did we say yesterday you should have done before you ever did anything on your calculator? Make sure it's in degree mode. So go to mode, make sure your degree is highlighted every time. Okay? Do you understand the big idea? Okay, so you're trying to get inverse sign, which is in blue, which means you have to do second.
Do that first,
Uh-huh.
and then you do that.
And then you type in whatever you're taking the inverse sign of. Now, those of you who are using your phones at home, remember you're typing in the numbers before you type in the trig function, right? So you would have to type in 3, 6, and then do second sign and enter. And again today, if you need to practice that on your calculator, on your phone, you're welcome to get it out and practice it. Make sure you know how to do it before you walk out of here. Don't go home tonight and then not know how to use your phone. Okay? So get it out, practice. Make sure you feel good about it. And if you don't, let me know and I'll come help you real quick.
Oh my gosh, I just did it.
Morgan, you with us so far? Okay. And again, if you don't have a will you have a graphing calculator at home to use, or will you use your? Okay. Okay, good. Because if not, they were practicing on their phones yesterday to make sure they know how to do it. I'm sorry, say it again.
It doesn't look like I have negative.
Wait, how would you do it on your phone?
Does it change? Yeah. Does it change when you turn it like this? So what do you need?
The negative cosine.
Oh, so you're gonna do. Oops. Where's your shift button? So inverse. So you're gonna do inverse, and then that gives you the
Okay,
inverse sign. Okay, you're welcome. Anybody else need help with your phone? Okay, we're going to move on then quickly up here. So this chart is in your notes. Find this in your notes. And this is where they're showing you. If you have the sine of angle A equals x, then you can take the inverse sine of both sides. That cancels. Inverse sine of this side. And now you have x. The inverse sine of x is equal to the measure of angle A. If you take the inverse cosine of both sides, those cancel, inverse cosine, then the measure of angle A is equal to the inverse cosine of x. Is that making sense? We're taking the inverse of the function on both sides of the equation using our algebra skills, and we're using the inverse because you can't divide by a trig function. So it's the same as taking the inverse. It undoes what the original function does. We're going to talk more about inverse functions in Algebra 2 and how an inverse undoes the original function. Okay? All right, so just to practice, if you need to here real quick, go ahead and type those in. Let's see if you can calculate those and use whichever device you want, your phone or the regular calculator. Just keep in mind that on the test you have to use my calculator, but at home you're using what you have there. So practice both ways so you know what you're doing. And definitely read your directions. And remember, these are angle measures. We're only doing inverses when we're finding angles. Yep. Not too bad. I'll get to a few harder application problems tomorrow. Maybe today. Maybe one on today's. Yeah, they're not too bad. Okay. Yes, ma'am.
I'm doing something wrong.
Okay.
So if I have it on second,
Mhm.
it's cosine.
Mhm.
But that says cosine
Okay.
is 90.
Your phone you have to type the angle in first when you're using your phone. You can't type in the trig function first. You're not doing times. Okay. Well, you're really not multiplying by it. You're just taking the inverse of it. But okay.
Oh,
But the big idea is you have to type in the angle measure first on your phone every single time, okay? Just like yesterday we had to type in the angle measure first, this time you have to as well. Okay, all right, here we go. Did you get 30, 58, and 35? Okay, don't forget it said nearest degree, and you should have degree symbols. If you are using inverse sine, inverse cosine, or inverse tangent, you should have degree symbols. You only use the inverse when you're finding an angle. You never use the inverse if you're trying to find a side. Sides are like what we did yesterday. We'll look for one of these ways first, and then we'll move on to this if we don't have a way. Okay, so we're going to look at some problems. I already said this, but I'm going to point it out again. To solve a right triangle means that you are finding every unknown measure. So you'll find all the unknown angles and side lengths. Everything. Okay, if you're solving a triangle. You're finding all missing parts. And then I would remind you, you can use any of these methods to find some of those missing parts. And then use your trig as if you have to at the end. So we're going to practice this first. It says find the unknown measures, round your lengths to the nearest hundredth. Be careful there because they're going to change directions. Lengths are rounded to the nearest hundredth. Angle measures are rounded to the nearest degree. So that means your side lengths get rounded to the hundredth. Your angle measures get rounded to the nearest whole number. Okay, so you look at the picture. First thing you're going to do is ask yourself, well, what all do you need to find if it says find all the unknown measures? So what are we looking for? ST, what else? Measure of angle T and measure of angle R. So notice I gave you 3 things, you're going to have to find the other 3. That's going to happen every single time. They have to give you 3 things, you'll find the other 3. So there's a lot of different things we could do here, but what's the first way we could find ST? Pythagorean theorem. So let's find ST using Pythagorean theorem. So we have 5 squared plus ST squared equals 5.7 squared. I know 5 squared is 25. Help me out with 5.7 squared. 32.49. We're going to subtract 25. And we get ST is equal to 7.49. Is that correct?
Yep.
And then, sorry, that's ST squared. And then we're going to take the square root. So ST is equal to the square root of 7.49. And we plug that into our calculator and round to the nearest hundredth. 2.74. And our units, do they give us any? No. So we would just circle that. ST is equal to approximately 2.74. Okay, so just using our Pythagorean theorem. Now here's my rule. Even though we now know ST is approximately 2.74, 2 reasons we're not going to use it. 1, if you mess up the Pythagorean theorem and you make a mistake on that answer, then you're making a mistake on everything else you do. 2, that's not an exact value. That's rounded. And we don't want to use rounded answers to find other answers or they just get further from the correct value. So we're not going to use this side. We're only going to use the 2 they gave us. Does that make sense? Okay, so practice that all the time. So now do you want to find T first or R first? I heard T. So we're going to find T first, okay? Again, label the sides you know. We're not going to use the one we just found, so label the sides you know. So what is 5 going to be labeled? Opposite. And what is 5.7? Hypotenuse. So which trig function should we be using? Not tangent, sine. So we're going to do sine of angle T. So sine T. Keep your angle there. Is equal to what over what? 5 over 5.7. Opposite over hypotenuse. And then new today, the only new thing is to solve for an angle, you're taking the inverse of both sides. On the left side, they cancel out. On the right side, you just plug it into your calculator. So we're going to have the measure of angle T, make sure you use good notation, equals, and then you'll type in on your calculator inverse sine of 5 over 5.7. And make sure you round appropriately to the nearest degree. So it's 61? Yes. Everybody agree? Yeah. Okay, I'm going to give you some advice and warning when it comes test time. Every year I have students who don't want to write enough down on their test because they're just grabbing that calculator and punching stuff in. But then if you make a mistake, I can't give you any partial credit. So if you don't show your work, even though I know you may think, well, I can just go straight from this to typing in on my calculator, then I won't give you any partial credit. But if you write everything down correctly and then your answer's just off a little bit, maybe you rounded wrong, you're only going to miss maybe 1 point at most. Okay? So show your work. All right, angle R. This is the only time I'm going to let you use a rounded answer. You could go back and do trig ratio again. But what do we know about all 3 angles in a triangle? They have to add to equal 180. So if we found that t was 61 degrees, then even when we find r, when we round it, it's going to round so that it is going to add to be 180. Does that make sense? So I'm not going to make you find r by doing trig ratios again unless you just want to. You can find it just by using the fact that all three have to add to be 180. So measure angle r would be equal to what? 29 degrees. Yes, and it will it will every time. So if you find it using your trig ratios and then round it, it'll still be the same. So that's why I'm going to let you use your rounded answer. Questions? Okay, there should be another one below that, right? You guys try it on your own. See how you're doing. So this could be doing what we did yesterday or what we're doing today. See if you can figure it out. I'll give you a few minutes to try and then I'll go over it with you. Is this problem using what we learned today? It's just yesterday, not at all what we learned today. Because how can you find the missing angle? Yes, or you can use the shortcut, 90 minus 58. So what's the measure of angle D? 32 degrees. So you didn't have to find any angles using what we're learning today. This goes all the way back to what we did yesterday. Could we use Pythagorean theorem here? Nope. So we're stuck with, and we don't have a special right triangle, and we don't have an altitude drawn. So now we have to do our trig ratios. Do you want to find EF first or DF first? DF? Okay. So we're looking for DF. So that means I'm going to call my DF X here. Label according to the 58 degrees. Again, the warning I gave you yesterday, I wouldn't use angle D just in case you make a mistake mathematically. You're less chances of making the error if you use what they give you. What do we label the side across from it? Opposite, and the X is the hypotenuse. So which trig function are we using? Sine. Sine of 58 degrees equals what over what? 14 over x. And then you can either put this over 1 and cross multiply, or he says in the video, when x is down below, you switch, you know. So when x is down below, you just switch those two. So that gives you x equals 14 over the sine of 58. And approximately, what is that? All right. Anybody have a question on DF? Okay, do we want to do Pythagorean theorem now that we know that side? No, we don't want to, though, because it's a rounded answer. We plugged it in and we rounded it, so we don't ever want to use a rounded answer. So we'll go back. We want to look for EF now, so I'll call that Y. We still have the 14 as opposite. What's the Y? Adjacent. So which trig function? Tangent. So we have the tangent of the angle 58 is equal to what over what? 14 over y. Again, y is down below, so we switch, you know. So we have y equals 14 over the tangent of 58. Type it in, what do you get? Approximately 8.75. Okay? You still should have the same answer, right? Okay. So this was EF. Sorry, bad notation there. Questions? Pretty easy? Kinda, sorta? Okay, so let's look at some different kinds of problems. I'm going to start with going through the next ones. We'll go back to the front that I skipped at the end. So this one, I just want to talk about it. We're not going to actually work the entire problem. The difference with this one is they don't give you a picture, right? What do they give you? Coordinates. So what are you going to have to do first? Graph it. That means they have given you 0 measurements. How many angles and sides does a triangle have? 3 of each. So how many answers are you going to have on a problem like this? 6. So you're going to have to graph the triangle first, and then you're going to list every single measurement. But there should be some you can find easily, because if it's a right triangle, you should be able to find for sure. In this case, this is horizontal, this is vertical. So what's our right angle? So you can write down measure angle P equals 90. They do give you 3, but you still have to kind of find them, right? What other side could you find really easily? PQ? What's PQ going to be? 5. Okay. And then what other side can we find easily? PR. And PR is, okay. Everybody agree? 7 there, looks right. So then you can label your picture. This is your right angle, this is 5, this is 7. And now it's just like what we did, right? So then we can solve. So we can do Pythagorean theorem first, or we could, since it's on a coordinate plane, use distance formula if you prefer. But Pythagorean theorem is probably easier. And then you can use what we're learning today about those inverses to find angles Q and R. Let's go ahead and do Q and R just for more practice on the inverses real quick, okay? But I'm not going to work the whole thing. So if I want to find angle Q, which 2 sides do I have? Good. So opposite and adjacent. Which trig function then do I want to use? Tan. So tangent of Q equals what over what? 7 over 5. And then what do we do new today to find an angle? Do the inverse. So the measure of angle Q is going to equal the inverse tangent of 7/5. And round to the nearest whole number, which is probably what they asked for there, nearest degree. What do you get? Say it again. 54 degrees? Okay. 54 degrees. Approximately. And so then remember, to find the third angle, you can just subtract it from 90 or add them and subtract from 180 because it's going to round to that value anyway. Okay? So if this is 54, what's the measure of angle R going to be? 36 degrees. So it's the only time I'll let you use that rounded answers when you're solving for the third angle in a right triangle. Questions? So the only thing we didn't finish here was Pythagorean theorem, and I know you guys can do that. Are we good? Okay, so in a problem like this on your homework, you're going to have 6 answers. Make sure you list all 6 answers.
How long from yesterday we don't do? It's like, wow. On that, Rizzy,
Oh, on the question on the homework, good question. So you'd already turned yours in early today, right? hmm
yeah.
So on the core math page from yesterday, there's a number 8. Is it on the back of the core math page? The last page on the, yes. There is a question that talks about finding the angle measure. I'm not going to grade it, so because technically we hadn't learned it yet, but if you want to do it, because now you know how to do it, you can. So it's, no, I won't give you extra credit, but just make sure you know how to do it, okay? But you don't have to do it now because I'm not going to grade it on it. Okay. So I'm going to skip this one because it's just another example. Same thing. Let's get to some that are different. Okay, here's a different one. So take a minute, read this. Okay, so big idea is this concept of percent grade. So the steepness of a road, when we think of steepness, what do we think of? The incline. And when you think of Algebra 1, what did we call the steepness of something? Slope, right? So when you think of the steepness, you're thinking slope, you're thinking incline. Now another word you can think of is percent grade. It's describing that steepness. So Filbert Street is the steepest street with a 31.5% grade. And down here at the bottom, it tells you that you can use trig ratios to change a percent grade into an actual angle measure. So they're telling us that the street has a 31.5% grade, but what does that mean that the angle of incline is? We want to know what is that angle that it's making. So that's what they're asking for. They tell you it's a 17.5 degree angle, but you can calculate and come up with that. Because remember that percent means something out of 100. So when they say 31.5%, they mean 31.5 out of 100. And if the percent grade means steepness, which means slope, then what they're giving you is the rise over the run. So when you think about your triangle that you can create, if this is ground level, and now I have this street which is on an incline, I can just draw a vertical line straight back down then to create a right triangle. And what we're saying is that this street is rising 31.5 feet for every 100 feet that it's running. Does that make sense? So if the steepness of the road has a 31.5% grade, it's got a 31.5 out of 100 slope, which means it's going to rise 31.5 feet when it runs 100 feet. And now, if we want to find that angle of incline, how far is that angle, we can just use our trig ratios. So which two sides do we have here in our picture? Opposite and adjacent. So which trig function will we use? Tangent. And it will always be that way because they're always going to give you the rise and the run. And so you're always going to be looking at the legs, which are the opposite and the adjacent. Okay, so it's going to be tangent of theta equals what over what? 31.5 over 100, which is your slope, basically. And so then you just take the inverse tangent of that value. And so if you're comparing it to what they told us, it was 17.5 degrees. Is that what you got when you looked at your calculator? Okay, so that's how they came up with that angle measure. And you may not think 17.5 degrees sounds like much, but if you've ever ran or walked on a treadmill or tried to walk or run up a hill, it doesn't take much of an incline for it to be a little bit difficult. I mean, I'm not in shape at all, but if I take my treadmill and I raise the incline even 4 degrees or 5 degrees, it's tough to run for very long on an incline. So 17.5 degree incline is a pretty big incline when you think about it. So it doesn't seem like much. All right, try this one on your own. See if you can get it. Yes, because it says to the nearest degree, what angle does the road, which this is the road, then make with the horizontal? So this is the horizontal, so the angle that that creates. Yes, perfect. Good job. It's not going to matter to me either way, but it's good practice because as soon as you get to pre-cal, that's how it's all going to be. No, not at all. Not at all. You're welcome. Okay, let's check it real quick. So it says you have a 7% grade. One more time just to make sure you're understanding that. That means 7 out of 100, and that is the percent grade, which is the steepness, which is your slope, right? So if I think about the road having an incline with my horizontal line, as that road inclines, which I made that too steep, then it means that the road is rising 7 for every 100 that it's horizontally going, okay? So rising 7 for every 100 that it runs. And we're looking for the angle made by the road, here's the road, and the horizontal, which is this line. So that's this angle right here. So we're going to use opposite and adjacent, which is the tangent. Tangent of theta should have equaled 7 over 100, which means theta was equal to the inverse tangent of 7 over 100. And to the nearest degree, what did you get? 4 degrees. Okay, again, doesn't sound like much until you go put yourself on a treadmill and raise it to a 4 degree incline and run for a little bit. And then you'll be like, forget it. Okay, any questions so far? Okay, I'm skipping the next one, and that should be all there is on that part, right? But we skipped the front 2 questions. So let's go back. These are the last kinds of questions you're going to see. Aww.
You ready for state? You gonna take state this Friday?
I was going to say, it's obviously working for him. He's doing a good job. Okay. All right, here we go. You guys ready? Last problem. So there's 2 examples, but it's the same kind of problem. So last kind of problem, okay? So it says use the trig ratio that the cosine of A is equal to 24/25 to determine which angle in the triangle is angle A. Okay, so they're wanting you to decide, first of all, do we take sine, cosine, or tangent of the right angle?
No.
No, not in here, not when we're trying to solve for our triangles. This is only acute angles, okay? So it's either going to be angle 1 or it's going to be angle 2. All right, so we're trying to decide which one of those, when we take the cosine of it, reduces to the fraction 24/25. Okay? So you're going to trial and error. So let's say that you think it's angle 2. You say cosine of 2. This is angle 2. Don't get confused by the number 2. So we're looking at cosine 2. What's the cosine? Which two sides? Adjacent and hypotenuse. So which one's adjacent to angle 2? 4.8, and the hypotenuse is 5. So you would go to 4.8 over 5, and you would see, is 4.8 over 5 the same as 24 over 25?
Okay, we got lucky.
Okay, or you could go a step further and take the inverse of, so you could say A equals the inverse of 24/25, and you could compare that to the inverse of 4.8 over 5. Maybe, if it's drawn somewhat. Yes. So is it the same? Do you guys understand how you can check it two different ways? If this 4.8 divided by 5 is the same decimal as 24 over 25, or you could solve this for angle A by taking the inverse, find out what is the measure of angle A, and then you could come over here and do the same thing. Take the inverse cosine of this and say, what is the measure of angle 2? And if they're the same, then it has to be angle 2. Was it the same? So the answer is angle 2. If it wasn't the same, then that means the answer has to be angle 1, because there's only two options. Huh? You don't have to show your work for the second, no. Like as soon as it's not this one, it has to be the other one. Okay, try the next one on your own and we'll check it. Oh, I'm sorry, it's missing, the ratio. Here it is, I'll show it to you. There you go. Yeah, you need to know sine A equals 8 over 17 or there's nothing you can do. This is missing.
Why is that? Why?
Sure. Or if you're using equals, you should really say measure of angle equals measure of angle 2. Or congruent if you leave off the m's.
Yeah, I use cosine.
What do you mean? Of this? Did you type in the exact same thing or did you type in?
I typed in this. It's wrong actually. It's actually no, it's not. I don't know what I'm doing now.
Okay, so raise your hand if you think it's angle 1. Raise your hand if you think it's angle 2.
Sure. All right.
Okay, so I'm going to show you one more time. Watch up here to make sure you're really getting it. So if we have two ways you could do it. First way is you could just calculate what is 8 over 17 on your calculator. And then you could come over here and you could say, okay, I'm going to start with angle 1. I'm going to find the sine of angle 1. And that's equal to the opposite over the hypotenuse, which is 27 over 30.6. And you could take the 30.6 or the 27 over 30.6 and approximate it. So are these two the same? No. So then that means it's not angle 1. Or the other way you could do it is to say, actually find the measure of angle A by doing the inverse. So you could do the inverse of 8 over 17. That's a 17. And then you could do the inverse of 27 over 30.6. Whichever way you want to think about it, are the angles the same? And you're telling me it's not, right? Okay, so that means it's not angle 1, so it has to be angle 2. You can check it though if you don't believe me. So angle 2, we're looking at sine. That would be opposite 14.4 over hypotenuse 30.6. So then you could take that value and reduce it, and does it reduce to 8 over 17? Yes. Are we good for real? Questions, anybody? All right, that is it. That's 8.